Okay, Assalamualaikum and good morning, everyone.
Waalaikumsalam, Doktor.
Good morning, sir.
Okay, so today we will continue tutorial on sketching root locus. So on Monday, I've discussed the first transfer function here. So now let's look at the second transfer function and also the last one. Okay, so let's look at the second transfer function. So maybe I can write it down first. Okay. Okay, so the first step is we need to find the poles and zeros. Okay, so again, reminder. So this is a unity feedback system. So unity feedback system with forward transfer function. So for a unity feedback system, you can find the closed loop poles and zeros straight away from the forward transfer function. So in case if you have a non-unity feedback, you need to simplify the system first and then find the poles and zeros assuming k equals 0 and k equals infinity. Okay, but for this case, we can straight away find from GS. Okay, so here we have our poles. So S equals 0, minus 2, and this one. So you can use a calculator to get this, the value of S from this. So you get minus 4 plus minus 2 square root 2, or 1.172 negative 6.828. Salah. Okay, salah. It's negative 4 plus minus 8j. Okay. Okay, and then 0, you have S equals minus 5. Okay, now you have 4 different poles and 1 0. So we have 4 poles, meaning that 4 poles means there are 4 branches. Okay, so 4 branches for root locus. And because we only have 1 0 and 4 poles, so we need to add 3 more 0 at infinity. Okay, so we know that the root locus will have 4 poles, 4 branches. So one of the branches will go to this negative 5, and the other 3 will go to infinity. Okay, so we roughly get the idea how the root locus will look like. And now we can roughly sketch the poles and zeros on S-plane.
Sir,
Yep.
nak tanya, kalau pool tu ada 5 and then 0 tu ada 3, so maksudnya akan 2 infinity dekat 0 lah kan? So dia ada 5 branches.
Yes, betul.
So,
So 3 branches tu akan pergi ke zeros tu. Lagi 2 akan pergi ke infinity.
Okay, thank you sir.
Alright. Okay, so kita let's sketch roughly the poles and zeros. Okay, tangan saya tak ada seni. Okay? Sengit bodoh lah. Tidak. Damn. Okay, so we have poles at 0, -2. Kenapa di atas? Damn it. Okay. -4 and -5. Sorry, -5 is a 0. And then we have 0 at 8j and -8j. Okay, so now we need to find on which real axis section that will have the root locus. Okay, so from here there is no poles or zeros, so we don't have root locus here. And at this section, we only have one pole. Okay, one pole before this section. Okay, so one pole is an odd number, so you will have a root locus on this section. And then on this section, we have one pole and another one pole here. So two poles, meaning that there is no root locus on this real axis. And on this section, we have two poles here and two more poles here. So meaning that we don't have any root locus on this section. Okay, so because it's an odd number. And lastly here, from -5 to infinity, because we have 4 poles and 1 0, so there are 5 things, so it's an odd number. So you will have a root locus on this section until infinity. Okay, so from here we can roughly get the idea how the root locus will look like. Okay, so from my experience, I think the root locus will look like something like this. Kita bal pula. So there's a breakaway point here, and then going to some JWs at this crossing. No root locus here. No root locus here as well. So there's a root locus here. So maybe the root locus will come from the pole, going to some break-in points, and one of the branches going here, one of the branches going to infinity. So if you look at this rough sketch, so we have 4 branches, one branches here, one here, one here, and another one here. And it validates the section of real axis that has root locus. Okay, so we have root locus here on this section, no root locus on this section, and another root locus on this section. Okay, so this is just a rough sketch that you can do, so that later when you calculate everything, you can sketch it more properly. Okay, so now yes, soalan.
Sir, kenapa kita tak pilih antara -2 dengan -4?
Yang ni rules yang odd number tu. Odd number tadi. So because we have here, yang section pertama ni, dekat section pertama ni, kita hanya ada satu poles. Kat sini satu pole. So satu pole is an odd number. So meaning that kat kawasan ni ada root locus. And then this section, from -2 to -4, before -2 and -4, we have two poles. One here and 1 here. So 2 poles, it's not an odd number, it's an even number. Meaning that kat kawasan ni, there will be no root locus. And then dekat section ni pula, -4 and -5, there are 4 poles, okay? 1 here, 1 here, 1 here, and here. So 4, meaning that it's an even number. So tak ada root locus kat sini, kat section ni. And then kat sini, yang last ni, ada 0 sini, 1. Ada 4 poles. So dia odd number. Odd lah, bilangan dia odd. So we have root locus on this section until infinity. So this is, we go back to, I think, rules number 2 or rules number 3. Yang odd number, apa benda tu.
Okay, sir.
Okay. And then, let's go back to question. So we need to determine the asymptote breakaway points. So let's look at asymptotes. So if asymptote, I think there will be no asymptote for this case. Macam tak ada, tapi yeah, why not? Kira je lah. I think there will be no asymptote because this is a breakout point. This is breakaway points and this is break-in points. So break-in and breakout points is always 90 degree. So you don't need to find the asymptote, okay? But just calculate. Bukan exam. Okay, so asymptote. You'll this intercept. So summation of poles minus summation of 0 divided by number of poles. So there are 4 poles minus 1. So we get -10 plus 5. -5/3. So we have asymptote. So -5/3 is pakai calculator. So it's 1.6 somewhere here. So we have asymptote here. Okay. And then the angle. So 2k plus 1 pi over 3, okay? Number of poles minus number of 0. So from here, let's assume k equals 0. So theta A equals pi over 3. K equals 1. Theta A equals pi. K equals 2. Theta A 5/3 pi. K was 3. Theta A 7 pi/3. So this is already exceed 2 pi. So we stop, calculate, and we don't take this as the asymptote. So we can sketch the asymptote. So it should be somewhere here. Nanti kita sketch balik, okay? and one here. Okay, but we will sketch it later. So we have an asymptote here. So the root locus, probably the breakaway point will be somewhere before this value, okay? Less than negative 1.6667. Okay, ada asymptote. Okay, so we found the asymptote, and then the next question asks you to find breakaway and breaking points. So breakaway, breaking points. So the formula is 1 over sigma plus 5, okay? 1 over summation of 1 over sigma minus zeros equals 1 over sigma minus poles, okay? So our poles is 0 plus 1 over sigma plus 2 plus 1 over sigma plus 4 minus 8j plus 1 over sigma plus 4 plus 8j. Okay, I think you can use calculator to get this. But whatever lah. So you get sigma plus 2 sigma squared plus 8 sigma plus 80 equals sigma plus 5. Panjangnya. Baik, calculator lah. Give up cari, okay? So carilah jawapan dia. Kita pakai simbol lab, okay? Tapi nanti korang try lah pakai calculator. Okay, so kalau calculator boleh try the solve function. Kalau dalam calculator FX Casio FX 570 ES Plus, kita ada solve dekat button calc tu, CALC. There's a function solve and also equal sign. Okay, so try use that. Maybe later I will show you a YouTube video about using this. Okay, tapi untuk kelas ni malah. Lamanya. Okay, dia ambil masa setahun nak kira. Okay, kita skip dulu. Kita tunggu simbol lab kira. And then we can proceed to JW axis crossing. So JW axis crossing, first thing that you need to do, you need to find the closed loop transfer function. Okay. So JW axis. So we need to find the closed loop transfer function. So this is your initial transfer function. So the closed loop transfer function is a unity feedback system. Okay. So unity feedback system. You can get k times s plus 5 divided by s times s plus 2 s squared plus 8s plus 80 plus k times s plus 5. Okay, so this is your closed loop transfer function. And then we take the denominator. So expand this and rearrange, okay? So let's expand this. Okay, and then rewrite. So we get s power of 4 plus 10s cubed plus 96s squared plus k plus 160s plus 5k. And then we can generate the Rapp-Hurwitz table. So start with s power of 4 and then s power of 3. So this is 1, 10, 96, k plus 160, 5 and 0. And then find s squared. And then this one, you get 5, 0. So this need to simplify. So we get 960 minus k minus 160 over 10. And then S1. So S1. Oh, again. And then this one, get 0, 0. And then S0. So S0. Sorry, ni kena divide. So this, and this, and this, we get 5, okay? Okay, so maybe dalam exam buatlah column dia punya garisan. So saya, sebab whiteboard ni tak ada garisan, ada garisan dia tapi itulah. Dalam exam buatlah garisan supaya tak pening. Okay, so dia kat sini. Okay, ni ada garisan juga. Okay, so make garisan so that you don't confuse yourself. Okay, so to find JW axis crossing, we look at row S1. So row S1 is the row that potentially will have all zeros in the row. Okay, so use row S1. Okay, so assume that this value becomes 0. So we'll have equals 0. And then simplify this. So we get K plus 160 times 800 minus K over 10 minus 50 equals 0. Okay, kelam kabut sikit because we have quadratic for K. So simplify. So we get negative K squared.
Sir,
Yep.
saya rasa yang 5 tu 5K.
Oh
Kan,
damn, lagi
sepatutnya.
susah kan? Okay, awak kira sendiri lepas ni. Okay, 5K betul. Thank you. Okay, so 50K. Okay, tak apa, kita simplify kan slowly. So we get, should be okay kan, tak ada adjustment yang teruk. Okay, tak ada. So here we get 800 minus 160. Benda simple pun dah jadi panic. 640K plus 160 times 800. So kalau dalam exam benda-benda simple, kosong darab 1 pun guna calculator standard lah. Okay, and then further simplified, so we get K squared plus 140. Okay, nanti kira balik, okay, sebab saya rasa macam ada salah somewhere. Okay, so we get a quadratic equation. So use calculator to get the value of K. Oh, okay, jawapan saya salah. Check. Okay, cancel lah soalan ni. Okay, tak apa. Nanti saya kira balik dan maybe bagi dalam group, okay? Okay, tak tahu mana salah. Okay, so when you find the value of K, what will happen is that there will be two value of K, okay? So take the positive one. So take positive Okay. Okay, because we assume that the gain is always positive. Okay, so take the positive value as your gain at the JW axis crossing. But solving this equation, it seems that you will get imaginary number. Okay, so salah, it's not an imaginary number. It should be a positive or negative. Okay, so you will get two values, one positive, one negative, and take the positive one. Okay, so after you get the positive k, as usual, use in row S2 and use k value to get the j omega. Okay, or the value of s. Okay, so the value of s, you will get a square root something. Okay, and with j. Okay, something plus minus j. Okay, so just a reminder, if you have a quadratic values for k later, take the positive k and then use it on row S2. And don't take the negative, and if you calculate you get imaginary number, salah. Okay, check balik. So macam ni salah, maksudnya saya ada buat kesilapan mana-mana. Senang kan jadi lecturer, tak tahu jawab, dah lantak ke situ. Okay, so we answered question C and D. Later I will calculate again, okay, if I have time, and I will give to you guys. And then we have also angle of departure or arrival. So let's look at our poles and zeros. So here we have complex poles. Okay, so complex poles, meaning that you have angle of departure. Okay, so if you have complex zeros, meaning that you have angle of arrival. So here we have angle of departure. So let's calculate the angle of departure. So to calculate, you can masih saya ingat, you have to sketch roughly so that you know which angle you are measuring. Okay, so we have poles here and here. Sorry. So we have 8J and another poles here and a 0. Okay, so we need to measure the angle. Let's say the angle of departure is here, let's say. So we need to measure the angle made by all of the other poles to this pole. Okay, so we need to measure the angle here. So maybe we name it theta 1, and this angle theta 2, this angle 90 degree, so 90 degree we name it theta 3, and this angle theta 4. Okay, so in root locus, angle of departure and arrival, as I said on Monday, is not very important. Or in MATLAB, later when you do your assignment or project, when you want to validate your angle of departure, you will see that in MATLAB, it doesn't show the angle of departure or arrival, because it's not really important to determine this in drawing the root locus. So for angle of departure and arrival, you cannot validate using MATLAB, okay? Or unless if you have some other ways to validate, that's fine. But to calculate the angle here, later in chapter 5, there will be useful, okay, to calculate the angle, especially in designing a controller. So later in chapter 5, calculating the angles from one poles to the other are important. Okay, so make sure that you know how to measure the whether to use tangent or whether to use 180 minus tangent or 90 degree plus tangent and so on. Okay, so here theta 1 is 180 minus tangent minus 1 8 over 4. And then theta 2, 180 minus tangent minus 1, 8 over 2. Okay, so it's not necessarily 180 degree. It can be 90 degree plus, okay? So depending on how you look at the angle, okay? And theta 3 is 90 degree. And theta 4, it's tangent minus 1, 8 over 1. And then to get the pole, the angle of departure, so 180 minus theta 1 plus theta 2 plus theta 3 minus theta 4, okay? Summation of theta of poles minus summation of theta of zeros. Okay, so let's calculate. So you get negative 47.7. So negative meaning that the angle here is actually measured from below, okay? So it's here. So so if you take 360 minus, so the angle so the angle should be earning by maybe somewhere here lah. Mana-mana lah, okay. I think it's plus, okay. But this is roughly the method, okay. I don't know what happened to me today. Semua serba tak kena. Okay, so this is how you get the angles. And to sketch the root locus, because we cannot find the JW axis crossing, so later you can do it yourself, okay. And here in this rough sketch here, so the JW axis crossing may be somewhere between 8J and minus 8J, okay. And the angle of departure, the breakaway point, I said just now, it should be less than this value, negative 5/3. So we have two breakaway and also break-in points. So when you solve this equation later, you will get two sigmas, okay? So one of the sigma will measure this point here. So sigma 1 here, and another sigma is here. Nanti kira lah, okay? Try lah buat. Okay, any question before we proceed to the next last tutorial? Apa soalan sejam? Okay, so if you don't have any question, let's do the last tutorial question. So we have the same transfer function and system. So we have k s minus 2, s minus 4, s squared plus 6s plus 25. Okay, so firstly, find the poles. So poles. So we have quadratic equation here. You can use your calculator. Okay. 1, 6. So we get poles equals minus 3 plus minus 4j, and then zeros, s equals 2 and 4. So here we have 2 poles and 2 zeros. So we don't have to add any infinity, okay? So here 2 poles, meaning that we have 2 branches. So we can now roughly sketch the poles and zeros. Sorry, bulat. And then minus 3. Okay, so let's determine on which section of real axis we'll have the root locus. Okay, so from this section to infinity, positive infinity, there will be no root locus. In between this section, because we have 1, 0 here, so we have root locus on this section. In this section here, we have two zeros. So 2 zeros, it's an even number, so we don't have any root locus on this section. And lastly here, in this section, minus 3 and above, so we have 2 poles and 2 zeros, meaning that we don't have any root locus on this section until negative infinity. So our root locus is only exists on real axis at this section, okay, the red line here. So if you can roughly sketch the root locus, so it should have this kind of shape. Okay, so one branches go to 1, 0, and the other go to the other zeros. Okay, so if you look at this rough sketch, the root locus only exists at this section, okay, on real axis, and it will have shape something like this, okay. So this is a rough sketch only, okay. So now let's determine the asymptote. So here, again, because we only have one breaking points, so we don't have asymptote, okay. But later, if you calculate the asymptote, here, for example, sigma A, so something. So the number of poles minus number of zero, it's equal number. So you will get something divided by 0, okay. So infinity lah. So meaning that there is no asymptote, okay. So if you have same number of poles and 0, meaning that the bottom here, the denominator will become 0. So no asymptote. So tak perlu kira lah. Okay, so we know that there is no asymptote. And then we can determine the breakaway and break-in points. So in this case, it's a break-in point, okay, because root locus breaks in because it starts from this pole and then breaks into the real axis. So we can find the break-in points. So again, equation yang menakutkan ini. So kalau simple boleh kira by hand. Kalau banyak sangat, nah ya Pak Abu. Sigma plus 4C Okay, so let's try simplified. So we get okay, kalau saya kira laju, harap maaf, okay. Korang kira lah macam mana sekalipun asalkan dapat jawapan dia. Saya kira laju sebab masa dah suntuk. Okay. Okay, tambahkan. Then we get okay. Guna calculator. So our breaking point will be at 2.89 and also negative 5.72. So there are two values here. So we can roughly again sketch this on our sketch here. So one of the point is here 2.8 and another one is negative 5. So we know that from this sketch, the only breaking points is this one, okay? Yang 2.8, okay? The other one is not breaking points because of the rough sketch that we have. Okay, so that's another way to determine which breaking points to choose later if you calculate, if you get more than one breaking points. Okay, so we choose this one as the breaking point, not this one because based on our rough sketch, it cannot go back. Okay, the root locus, the direction is to the front. Okay, because it will go to this zeros. It cannot go back. Okay. So that's about breaking points. And then we can now determine the JW axis crossing. Okay, so JW axis. Firstly, we need to determine the closed loop transfer function TS. Okay, so it's a unity feedback. So unity feedback, you can determine the closed loop transfer function. Tengok GS je, okay. Okay, then expand this to get the denominator. So you get k plus 1 s squared plus minus 6. So 6 minus 6k times s plus 25 plus 8k. And then you can generate the route width table. Okay, start with s squared and then followed by s1. So as we fill this alternatingly. And then find row s0. Okay, so this is simpler, okay, berbanding yang sebelum ni. So use row S1 to get K. So 6 minus 6K equals 0. So we get K equals 1. So this is the gain value at JW at this crossing. So use this on row S squared. So use S squared. So 2S squared plus 33 equals 0. Okay, just replace K with 1. And then find the value of S. So S equals plus minus plus minus 4.06 J. Okay, so this is the JW axis crossing. Any gain value. Okay. And now we can determine the angle of departure or arrival. So again, from our sketch, so we have complex poles. So yes, soalan?
Sir, yang 2S square tambah 33 tu dapat mana sir?
Square. Mana tu?
Yang tadi, yang dekat.
Oh ni, row S2. Ni, S squared tambah ni. So K sama dengan 1. 2S squared plus 25 plus 8K, K1. So 25 plus 8, 33 equals 0. So just generate the polynomial here. So S squared 0, S0 kat sini. Okay, always use row S1 to find K and use row S2 to find the value of S. Okay. Okay, and then we have complex poles, so we have angle of departure. So angle departure ni traumatized jugalah. Okay, so we want to find this angle. So first we need to measure this angle, theta 1, and then this angle, theta 2, and then we need this angle as well. So it's a 90 degree, theta 3. Okay, so 3 angles to measure. So theta 1 equals theta 1 equals 180 minus tangent minus 1, 4 over 7. Theta 2, 180 minus tangent minus 1, 4 over 5. theta 3 is 90 degree. So the angle of departure, saya lupa formula dia. Rasanya 180 plus minus. So theta 90 degree minus theta 1 minus theta 2. Okay, so always summation of poles minus summation of 0. Okay. So calculate. Oh my god, ni dulu. Okay, and then so we get 381 degree. Rasanya salah. So this one should be okay, so I think the formula is not correct. Okay, I think it's plus. Tapi later you guys check again. Okay. So you get the angle. So the angle should be somewhere here. Okay. But later you guys can check again the correct formula. Okay. So we get the angle of departure, and the sketch you can sketch properly by adding the JW axis crossing 4.06. So if we sketch, so and then the breaking points. So your root locus should be okay, dia punya JW axis tadi dekat sini somewhere 4.06. So and then okay, lukislah cantik-cantik. So one go to this 0 and the other one go to the other 0. Okay, don't forget the anak panah, the arrow to represent the direction. Okay. Okay, so that's it. So a little bit about root locus. So let's go back to the definition of root locus. So root locus is actually a plot of poles when we vary the gain k value. Okay, so actually the plot here represent the value of poles when we change the value of k. So at k equals 1, it is the value of poles at the JW axis crossing. So this is determined from the route width table just now. So we get k equals 1. So k equals 1 here is the value of k at JW axis crossing. So this k value here, so at k equals 1, it's the value of k at JW axis So we know that when poles are at the JW axis crossing, meaning that the system is marginally stable. Okay. So at this point here, the system is marginally stable. So let's say if we use k equals 1 in our system for this transfer function, we get a marginally stable system. Okay, the system will oscillate indefinitely. And if we use k value less than 1, we will get a system that has pole at this section of S-plane. Okay, meaning that our value when k less than 1, our poles are located on left-hand side of the root locus or of the S-plane. So meaning that for k less than 1, the system will become stable. Okay. So if we use k larger than 1, then the poles will be located on right-hand side of the S-plane. So any poles that we use, let's say this poles at this gain, let's say k something, it will produce an unstable system. Okay. So here we can see that when we change the value of k, we get either stable system, marginally stable system, or unstable system. But if we just simply change the k, let's say in MATLAB, you change the k without calculating um, what value of k, so you don't know, okay, whether the system is stable or not. So by producing the root locus, we can first determine this k at JW axis crossing, and from here we can uh, change the value of k. So here in this case, we change the value of k so that it cannot be larger than 1, because we know that if we change k bigger than 1, then the system will become unstable because it passes this JW axis crossing. So this is how you later maybe in determining stable system, maybe in your project later, maybe if you draw root locus ke pakai MATLAB, you know that if you change uh, k value to a certain value, whether it's stable or not by finding this k at JW axis crossing. Okay, so that's basically the purpose of root locus. Okay, so we finished our lecture about root locus. I think 4 lectures. And starting next week, we are going to chapter 5. And we will look at how we can use root locus again. How to use root locus to design a controller suitable to uh, control a system to what we desire. Okay, so hopefully you guys can go back to root locus topic and try to understand some basic concept like how to find k at JW axis crossing, uh, the root locus shape starting from poles to zeros, and the symmetrical shape of the root locus, and also how to find the angles, even though not important in root locus. Later in next lecture, next chapter, it will be very important because we will do a lot of angles calculation. So any question before we end this lecture for today? So if you don't have any question, you can try do your project part 4, and any question that you want to ask later, you can just text me on WhatsApp. Okay. So thank you very much. Assalamualaikum and goodbye, everyone.
Thank you, Doctor.
Thank you,
Thank
Doctor.
you.